The Earth system is a system of spheres. We have the atmosphere, the outer envelope of gas, and then we have the hydrosphere, which is all the water, whether it is salty water, frozen water, fresh water, and the cryosphere, snow, ice, glaciers, the frozen tundra, and the biosphere is all the living organisms, and the lithosphere is the solid earth. So the top of the earth is the lithosphere, and those spheres all interact with each other, right? The wind blows, the um, water makes waves, the ocean freezes, it becomes a cryosphere. All organisms live in all the different spheres. And the solid earth, of course, gets weathered by the cryosphere, the biosphere, the hydrosphere, the atmosphere. So they're all interacting. When you change one sphere, you change another sphere, the butterfly effect. The Earth is unique in our solar system that it's in the habitable zone. And that basically means it's far enough away from the sun that's not too hot. We keep our atmosphere, but um, it's close, but not too far. So we still get the warmth from the sun, but we're not too close that it blasts away our atmosphere and boils away our water. We have that liquid water, and that really sets up our biosphere, right? And the weather in our atmosphere and our hydrosphere. We have all that going for us. The Earth is mostly not Earth. It's mostly ocean, and 71% of the Earth's surface is ocean, lakes, and rivers. The dry land is only 30%. We have a whole class you could study the oceans in oceanography here at ASU. This is a funky diagram, but if you pay attention to it, it's really neat. What it's showing is sea level is 0. There, the line in the middle. I can trace that line here is sea level, and above sea level, most of the land surface is within 1 kilometer of the ocean. That's about 3,000 some 3,200 and some feet. So basically up to Boone. What are we, 3,333 feet above sea level? So from Boone down to the ocean, most land is within that elevation. Not a lot of land is much higher than that. When it gets to the ocean basins, most of the ocean is steady here at about 5 kilometers deep. So most seafloor is 5 kilometers. Most of our land surface is in that first kilometer of land. So the extreme highs and extreme lows are like the rare points, right? What is the Earth made out of? If we were able to take the Earth and squish it all up and melt it, pick out all the atoms, most of the Earth would be iron. That makes the bulk of our core and a lot of the mantle. Magnesium, oxygen, and silicon make up the other big percentages, and then nickel, sulfur, calcium, aluminum, and other make up the rest. The most abundant most abundant mineral in the Earth's crust is a combination of that aluminum and silicon and oxygen, or a aluminosilicate, which is a group of minerals called the feldspars. So this is the whole Earth. The crust is different than that. Like I said, it's mostly feldspar. Okay. We're gonna go over just some terms like what is this Earth made out of. So the elements are combined in different ways. There's a group that are the organic compounds, those carbon-based molecules. Some of that, most of it associated with life. Move my face over here on top of the granite. We have minerals. These are crystalline solids. Most of the minerals in the crust are silicates. They're the most common type of mineral with that silicon and the oxygen. There are solids that are not crystalline, those are called glasses that are solid on the Earth's surface. There's rocks. Rocks are aggregates of minerals. So a rock can be monomineralic, it can have one mineral, but most rocks have more than one mineral. So the three rock types are igneous, metamorphic, and sedimentary. And we'll talk about all of those three in later chapters. All right, more terms. Grains. So grains is a term we'll use in this class. Another one would be sediment. So these are loose grains. Metals are those composed of metal ions. Melts. So when the solid earth turns to liquid, we call it a melt. There's also volatiles. Those are ones that, excuse me, easily transform into gases like evaporate. There's also the term clast. That would be a chunk of a pre-existing rock is another term that we use pretty regularly.